Buddy, I'm going to call this lesson 10A3C, but really, chapter 11, lesson 7 in textbook, volume of pyramids and cones. How much ice cream would fit in that ice cream cone? How much stone would it take to build a solid pyramid? First, I want to pause. Whatever the assignment number, if you have this assignment, check your answers. I'll hand you the back page in just a second. And pause and check these out. Come on back when you're ready. So folks, we're going to take everything that we learned with 1 and 2 and then 3-dimensional volume, but instead of doing prisms, cylinders, today we're going to do pyramids and cones. Sooner or later, you're going to do what we call composite 3-dimensional figures. But for today, we're going to focus on find the volume of pyramids and cones. All right, whatever the assignment number, whatever the date, pause. Come on back when you're ready. Once again, ladies and gents, we are not going to use 3 and 1400ths. We have a very nice pi button on our Desmos calculator. That's what we will use. Now, before we do anything, I'm going to show you a couple videos, but I want you to make a prediction first. I want you to predict how many of these pyramids, or any pyramid for that matter, how many pyramids would fit inside a prism with the same height and the same base. Again, if I remove this, I'm asking if you could crunch up, slice up, and wedge in how many pyramids would fit inside a prism with the same height and same base. Go ahead and write your answer off to the side. You're just making a prediction. Maybe you're going to write 2, maybe you're going to write 5, maybe you're going to write 3.5, whatever your prediction is, write that prediction down. Pause if you need to and think about it. Come on back. Let's do the same thing. I'm going to ask you to predict again. This time, how many cones would fit inside a cylinder? Again, with the same height, same radius, which I suppose also means the same diameter. So write a number down anywhere you want. How many cones would fit inside a cylinder with the same radius, diameter, and the same height? All right, so you made some predictions. If you need to, pause. But what I'm going to do here is I'm going to go to a video that I found on the internet. Maybe I could try to share the link so they get the credit for it. And I'm going to speed it up. All right, so here's the video. Notice pyramid, there's one of them. So imagine scrunching a pyramid. One of them would fit there. Here's going to be the second one. Let's see what happens. So that's 2 pyramids that fit inside a prism. Oh, pretty much exactly 3, ladies and gents. So with that in mind, I'm going to point out that 3 volumes of any pyramid will fit inside 1 volume of a prism, as long as that prism has the same height and the same base. Now, if with your permission, I'm going to write this, although I'm well aware that some of you would prefer writing, look, Mr. Cowan, it's length times width times height. So I'd just rather write that. That's fine. On the other hand, what if you just want one of the volumes of the pyramid? Well, in order to get rid of times by 3, we would have to divide by 3, as long as we're fair to the other side as well. So the volume of one pyramid is equal to, tell you what, let's just write 1/3 of the surrounding prism. Again, you've already done prisms. The key is that a pyramid is precisely 1/3 of what surrounds it. So note the 1/3. All right, now let's go on. If you need to, pause, rewatch that video. But I'm going to go ahead with the cone to cylinder relationship. I'm going to speed this one up as well. So they're going to show you right at the beginning of the video. Same diameter, same radius. You're going to fill it with water. All right, how many of these cones will fit inside? Let's take a look. Count it. That's 1. Filling it up with 2 right now. Ooh, number 3. There it is again. 3 cones inside of that one cylinder with the same height, same radius, same diameter. So if you'd allow me, 3 of the volumes of a cone is equivalent to 1 volume of the cylinder. Maybe I should just write pi times radius squared times height. But if I just want to know a single cone and its volume, we go ahead and divide both sides by 3, excuse me. So if you find the surrounding cylinder and then you cut it up into 1/3, you will then have the volume of any cone, circular cone that you would like. All right, ladies and gents, so at this point in class, I've offered you a reference sheet. Notice how both of these are similar. They both have a third, they both have a height, and no matter what this base is, maybe it's a length times width, maybe it's a 1/2 base times height. If you have length times width times height, that's 3 dimensions. If you have pi times a radius times another height, that also is 3 dimensions. So quite a bit of similarities between these two figures and therefore their volume formula. On the other hand, one's got a circle, so you're going to see a pi in it. The other is a pyramid. It has edges, no curves, so there will be no pi involved. Now let's see if we can use that information to do 2 examples before we start our homework. First one, just listen to my think aloud, so I'm going to say everything I'm thinking in my head. The very first thing I got to do is figure out which formula to use. So I'm looking at the shape. It has no curves, so it's not a cone, it's not a cylinder, and it's not a sphere. Is it a prism or is it a pyramid? Well, prisms have not just one, but they have 2 bases. There will be a base on the bottom and a base on the top. Even if that sucker is knocked over on its side, you should see 2 bases. Conversely, pyramids have only 1 base. Also, if I could point out, prisms, yes, have 2 bases. They're also made up of a bunch of rectangular faces on the lateral faces. Meanwhile, pyramids naturally have a lot of triangular faces. So all that is to say, I can quickly see that this shape is a pyramid, not a prism. So I'm going to need the 1/3. 1/3, whatever its base area is times its height. Now, I like the base area, but some of you go straight to saying, well, Mr. Callan, I can see pretty quickly that base area is length times width. So we'll go ahead and we'll substitute in 1/3 times 5 times 6 times 4. Can I point out, please, that a 5 by 6 rectangle is the same as a 6 by 5 rectangle? So it doesn't matter to me if you write 5 times 6 or 6 times 5. If I multiply 1/3 of 6, that'd be 2. 2 times 5 is 10. 10 times 4 is 40. This one, it's kind of nice. We do have an exact answer. Beware, though. Sometimes that third will make for an everlasting decimal, and we'll want to round it to the nearest hundredths place. But in this case, we have an exact volume. So again, think again about where Mr. Callan got this. First, I identified the shape. It was a pyramid. Then I noticed which the base area was. It was a rectangular pyramid, so length times width. Substituted the numbers in next and calculated it out. Now let's go on to the next one. Similar process. First thing I do, what kind of 3-dimensional figure is it? Now it's got curves. Is it a cylinder, cone, or sphere? This is a cone, so I know immediately what the formula is. Can I just point out to be abundantly clear, you could theoretically start with the same formula. Only in this case, the base area is going to be a circle. So you're going to find those circles, you're going to stack it up 8 centimeters tall, and then you're going to say, well, look, that's a third of the surrounding cylinder around it. So don't forget that 1/3. Pause if you need, rewind, listen to that part again. Now in this case, I have to identify the dimensions. I don't know why, I usually go to the height first for whatever reason that's easiest for me to pick off. So the height's 8. Now I examine the picture. Is that 3 a radius or a diameter? Oh, it's a radius. It starts at the center and goes to the exterior of the circle. So do not double the 3 to make 6. Don't cut it in half to make 1.5. Keep the 3 for its radius. Don't forget, I know this seems obvious, but if you have 3 dimensions, if you want to know the area of that circle, you need pi times radius times another radius. Some of you might even write that out as 1/3 pi times 3 times 3 times 8. Okay, speaking of, 1/3 of 3 is 1, times 3 is 3, times 8 is 24 pi. That is the exact answer. If we multiply that out, oh, previous teacher must have gone to the nearest 10th. I'm going to go to hundredths place. So look at these problems. How are they similar? How are they different? One thing you'll notice, they both have cubic units. Why is there cubic units and how do you know? If it helps, next to every dimension, you can actually write the unit next to the dimension. And so not only do you take care of the numbers, 3 times 3 times 8 times a third, you also can say centimeters times centimeters is square centimeters, times another centimeters gives us cubic centimeters. Same thing here. Meters times meters times meters should be cubic meters. Just know that you're looking for how many cubes of ice fit in that freezer, how many cubes of rock build that pyramid, how many cubes of ice cream will fit inside that cone. What else do you notice that's similar with those problems? Pause the video if you need. Take a look. What's similar, what's different? Once again, they both have that 1/3. They both have a height. But the area of the base, that is the different part. This was a rectangular pyramid. This was a circular cone. And they both have 3 dimensions. Length times width times height. Radius times another radius times height. That's 3 dimensions as well. If you only put 2 dimensions, you're only finding a surface area. So that's what I got, folks. Only 2 examples. I want you to continue into the homework, whatever that homework number is, whatever the date is. If you're in class, we'll do a few of the problems first. Beware if you check your answers in the back of the book. They will use 3 and 1400ths. We're going to say, no, sir, no, ma'am. We can do a lot better with our pi button. So you can go ahead and come up with an exact answer and an approximate answer for any problem that's finding the cone. Whoops, that's not going to work. All right, that's what I got for you today, ladies and gents. Take care. Do well. Let's grow. I'll see you.